Okay, so the volume of water in meters cubed in a reservoir is given by that, where T is the time in hours after a pump is activated. What is the initial volume of water in the reservoir? What do you guys think you're going to do here? So initial volume of water at this particular point, you would sub in T equals 0 into that. So you're looking for the volume when time is 0. So -8, 0 squared plus 80 times 0 plus your 40. So the volume is 40 meters cubed when time is 0. Okay, so that would be the answer to the first question. Then at what rate is the volume of the water tank changing after exactly 4 hours and then 10 hours? So remember, when they say rate, what are they looking for? That's when you take your first derivative. Okay, so let's take the first derivative here. So this becomes -16t plus 80. Okay. The rate when t is 4. So v dash 4. So -16 multiplied by 4 plus 80. So the rate at that particular point would be -24 and meters per hour probably, but they don't ask you for the units, so you don't have to include this here to be -24. Then when it's 10, here it's -16 multiplied by 10 plus 80. Oh, sorry, this is 80. So sorry, let me just correct that. -16 times 4 plus 80. Okay, so it's plus 80. This is 16. Okay, then for the next one, it would be -80. Okay. So any questions so far? Okay. Then after how many hours does the volume of the water in the reservoir increase at a rate of 48 meters cubed per hour? Decrease at a rate of 32 meters cubed per hour. So here it's increase at a rate of 48, and then there's decrease at a rate of 32. So we need to solve for t. We're still using the same velocity formula here, the -16t plus 80. What are we going to do that's different from what we did in the second question? We are going to take the answer they give you, the 48, and it's positive. So you have to show that this is 48 equals -16t plus 80. Okay, and then you solve for t. So -16t, 48 minus 80. We're left with -32 here is equal to -16t. So t is equal to 2. Right. Then it was decreasing at a rate of 32. So what would you have to do there? If it's decrease, it would be -32 equals -16t plus 80. Okay. So -32 minus 80. This gives us -112. Divide both sides by -16. T here is equal to 7. Okay. All right. Do these two make sense so far? Now, after how many hours does the volume of water in the reservoir reach a maximum? Okay, so remember you had your V dash T here is equal to negative 16T plus 80. It reaches a maximum when what? We have to take the
double derivative.
Second derivative.
okay,
Second derivative.
okay, so if we take the second derivative, okay, this becomes negative 16. Does this help us in any way?
No.
Okay, so now,
Wouldn't you equate it to 0?
right, so you will take this thing and make it equal to 0. So 0 equals negative 16T plus 80. Okay. Because remember, we had already taken the first derivative, you make it equal to 0. So 16T equals 80. I'll tell you what this value is going to help us with now. So divide both sides by 16. So 80 divided by 16, that gives us T is equal to 5. Now, this is where your graph is a maximum. So that's the point T is equal to 5. Now, this second derivative here, if it is negative like this, it tells us that your graph is a maximum. If it was positive, it would tell you that your graph is a minimum. Okay, so that's what this tells us. If it's negative, this is a max. Or you had a frowny face graph, therefore it's a max. If it was positive, you have a minimum, therefore you had a smiley face graph. Okay, so T is equal to 5. So that's the time, 5 hours. Now, what is the actual maximum volume here? Maximum volume, you would then take that T is equal to 5 and plug it in here. So T equals 5. So V5 equals negative 8, 5 squared plus 80 times 5 plus 40. Okay, let's work that out. Negative 8 times 5 squared times 5 plus 40. Volume is equal to 240. Now this is the maximum meters cubed. Okay, so that was an example of an optimization type question. All right. Okay, now.
Ma'am, when you working out the minimum and the maximum, is it double derived equal to 0, or is it just one derived?
Say that again. Okay, so remember the difference this time, it was not a cubic, it was a quadratic function. So we only did it once.
Okay, but for a cubic, if you're working out the min and the max, you have to do it twice. I'm asking.
Okay, I'm gonna try and look for another one with a cubic and then we'll do it. But let's go on to this question here. So this is the question that you had requested earlier. So given f of x equals x to the power of 3 minus 12x plus 16. Okay, so those are cubic, right? And we want to solve it. So the first question would be, show that x minus 2 is a factor of f of x. Okay, people. Now, whenever something is a factor, right? So this is the factor. For it to be a factor, let me teach you a shortcut, right? Put your calculators into table mode, okay? If you put your calculator into table mode, okay, you'll get something that says fx equal. For something to be a factor, we want the value of fx to be equal to what? To be equal to? 0. Right? So let's take this and plug it into your calculator. This is a shortcut. But you obviously have to show all your working. I'm going to show you how. So we want to show that x minus 2 is a factor. To show that it's a factor, you have to sub x equals 2 into f of x. So they don't always give you this first thing here. They show that x minus 2 is a factor. This was a nice question because they already told you one of the factors. If they hadn't, let's plug our this equation here into your calculator. Does anyone not know how to do it?
I don't, ma'am.
Okay, so do you have a Casio?
Yes, ma'am.
Okay, so go to mode, press mode, and then select table. I think that's option 3 on your calculators. Okay, so once you're in table mode, your calculator will say f of x equals. Okay, you want to plug in x. The x, you're going to have to press alpha and then press alpha and then press the curly bracket. It looks like that. Above the curly bracket, you'll see the x. Have you done it, love?
Yes, ma'am.
Okay, then raise it to the power of 3.
Okay, ma'am.
And then press the replay button or the arrow button going that way so that you come out of the power or the exponent.
Okay, ma'am.
Okay, and then punch in minus 12x plus 16.
Okay.
Okay, then press equals. After you press equals, you'll get to a point where it says g of x.
Yes.
Oh, are you there?
Yes, ma'am.
Okay, then press equals again. Now it's going to give us a start. Okay, so remember by g of x, you're not punching in anything. You leave it blank, just press equals.
Okay.
Okay, so now what I'm going to do, I want you to select, say your start value, say negative 6. Okay, so negative 6, that's your start. So you punch in minus 6, press equals. Then for your end, let's make it positive 6. And then you press equals. Okay,
ma'am.
then your step. Okay, the step, I want you to make the step equal to 1.
Okay.
Okay, then press equals. Now, what you get on your calculator, you're going to get x, and then you're going to get f of x. I want you to look for a value of x where you can see it being equal to 0. What's the first value of x that you see that's equal to 0?
Negative
16.
4.
Brilliant. Okay, so this first value, that's actually one of our factors. So x is equal to negative 4, that's a factor. Let's go and see, is there another one that we can read off here? Scroll down, what's the next
2.
one you see? Perfect. The
2.
next one is 2, so that's another factor. X is equal to 2. Let's carry on. Okay, so those are the ones we've seen. So we've identified 2 factors, okay? This is a shortcut, it's a trick, guys. So using this, if they hadn't told you that x minus 2 is a factor, just by looking at this or doing this table method, we already know that, oh, okay, x equals 4, that's a solution. That means x plus 4 is a factor, right? What's the other factor we found? X equals 2. Therefore, x minus 2 is a factor. Okay.
Isn't it x minus 4 is a factor?
Okay, so these here, these are the solutions. These are the actual solutions. These are solutions. Okay, or roots. Yes, honey.
Would you always start at negative 6 and end at 6?
No, so you can even, because we're looking, remember the factor theorem says you look at the last value and think about all the factors of positive 16. I just chose a smaller range. So all the factors, you can actually say, I'm going to start from negative 16 and go to positive 16, because that's where all the factors of positive 16 lie. So you can do it that way. If you get an error because of insufficient memory, you can say, okay, I'm going to make my start point negative 16, endpoint 0. Then the next time you go back and try, you make your start point 0 up to 16. Then you'll be able to see all the factors. Okay, so let me go. So these are the solutions or the roots to the equation. The factors, x plus 4 is the factor. Okay, and then if it's x is equal to 2, that means x minus 2 is a factor. Let's say arbitrarily, right? I'm not sure saying this is correct. If we got another one that said x minus 16 is a root, then the solution would be what? I mean, the factor would be x plus 16. Let's say we got x is equal to 8 as a root or a solution, then the factor would be x minus 8. Okay, do you guys get the difference between the solutions and roots and then the actual factors?
Yes, ma'am.
Okay, perfect. So going back to the actual question, right? To prove that something is a factor, you have to substitute in x equals 2 into the equation. Then if your answer is equal to 0, then it's a factor. So you show this step. Okay, we're going to, oh my goodness, I don't know what my, oh wow. Sorry guys, it's just acting up. Okay, here we go. So what you would do here, sub in, you want to see what your f of x is going to be. You have to show this, 2 to the power of 3 minus 12 times 3 plus 16. Okay, work it out. If you work it out and you see that your answer is equal to 0, then you conclude, therefore, x minus 2 is a factor. Okay.
Ma'am, if let's say I'm running low on time, can I just
Yeah.
say f of 2 is equal to 0?
Yes, you can. But I would say, because remember, you have to show all the steps, you have to show the substituting in. Yeah, show
So I
the
wouldn't get full
substituting.
marks just by saying f of 2 is equal to 0.
No, I don't think so, because this one
Okay.
it's 2 marks. So they want to see all the steps in between. So yeah. Okay,
Thank you, ma'am.
so perfect, right? Now f of x, let's factorize it completely. So it depends who your teacher was, how they taught you how to factorize. So I do the dividing way because I think my students understood it better. So if x minus 2 is a factor, okay, I want to divide it into x to the power of 3 minus, or you put a placeholder because there isn't an x squared. So you have to put that placeholder. Then the next one is negative 12x. Okay, and the last thing is 16. Okay, you don't have to do this entire process of dividing, because if x minus 2 is a factor, you know you're going to multiply it by something that has 3 terms. That will then give you x to the power of 3 minus 12x plus 16. So what do I need to multiply x by to give me x to the power of 3? That would be x squared, right? Yes or no?
Yes, ma'am.
Okay, now the trick is finding the middle term. What would I need to multiply negative 2 by to give me positive 16?
Negative 8.
Perfect, right? So negative 8. All we're missing now is the middle term. So this is where I say, okay, go and divide here so you can see what the middle term is. X cubed divided by x, that's where you get x to the power of 2. Now you have to distribute here. You distribute that, then you get x to the power of 3 minus 2x squared. So this is why it's important to put that placeholder. Now you subtract the first from the second. So x squared minus x squared, you get 0 there. Now remember, this is a negative on the outside, and you have this negative here as well. So a negative and negative, that's going to give you positive. So 0 plus 2, you're going to get 2x squared. So this is where you get the solution to your middle term. 2x squared divided by x, this is plus 2x. You don't have to go any further. This here is plus 2x. Okay. Yeah, so I don't know how you other teachers taught you how to do that one, but I do this division thing because my kids understood it. Any questions? Yes, no? Okay, so let's see. Now we've done the division. We've got this. What was the second question? Oh, factorize f of x completely. So we haven't fully factorized it because we're now at the point where you have x minus 2 with the x squared plus 2x minus 8. How can I then factorize the second part? So you're going to have 2 brackets. Okay, remember, keep in the back of your mind that one of the solutions we got was what? X is equal to negative 4. Right, so that means we need to make sure that we have the factor x plus 4 there. So factorize this one. So one of them we know is positive 4, and the other one is negative. So 4 times negative 2, that gives me negative 8. 4x minus 2x, that's 2x. So from this, that's completely factorized. Okay. Whew. Okay, so that's how you completely factorize it. Then determining the x and y intercepts of the graph. Okay, how do you find the x intercepts? What would you do?
Y
Y.
equals 0.
Perfect. You make your y equals 0. So, oh gosh. Sorry, guys, okay. To find the x intercepts, we make y equals 0. So from this, straight away, we can see that the x intercepts, which are the roots, x equals 2 and x equals negative 4. Can you see you're going to have 2 of these? That means the turning point is going to be on that particular point there. Okay. Then, so those are your x intercepts. Now to find the y intercept, we're going to make x equals 0. So the original thing you had, what do you guys think the y-intercept is going to be? If you had x to the power of 3 minus 12x plus 16. The intercept.
16.
Perfect. Okay. All right. So now you've got x and y intercepts. Y is equal to 16.